Let's start with the simplest feature of classes, instance variables. Instance variables provide a way of storing data inside of an object. And you can call them instance variables or data members or fields. And although in real object-oriented programming you can do a lot more than just instance variables, the idea of grouping variables together inside a containing object is so useful that even non-object-oriented languages had such an idea. So for example, in Pascal you had records, and in C you had structs, and they were basically a way of grouping instance variables, data members, fields together. So inside of the class definition, you declare some fields. You can say whether they're public or private. I'll discuss the distinction later. You give the type, like string or like int, and you give the names of the fields. Now, we'll see later in the next section that it's almost always better to declare your instance variables private, not public. In fact, you can say that it's always better to make them private, except when they're constants. They can't be changed. But in order to do this, we need some additional tools in our toolbox. We need to know how to hook instance variables to the outside world with accessor methods, and we don't know how to do that yet. So temporarily, we'll make our instance variables public, just so that we can see how instance variables work, but keep in mind that you'll make them private later, and by the end of the next lecture, you'll know how to do that. Okay, so the whole point is that instance variables let you group variables together inside of an object, and those values, those instance variables, persist over time. As long as the containing object is around, the instance variables are around. So suppose you had a class called person, and person had an instance variable called first name. If you assign to the first name at one point in time, and later you try to read from the first name, unless you have some code that has changed the value in between, the value is still the same. So the whole point of instance variables is that they're pieces of data that persist, that keep on, that stick around as long as the object sticks around. Some people say that object-oriented programming has three top-level, high-level features: state, behavior, and identity. The instance variables provide this state, the data that persists over time. All right, let's look at an example. I'll skim this example first to give you the gist of it, then come back and look at it in a lot more detail. So first I define a ship, and I say that ship has 5 instance variables. 4 instance variables that are of type double, x, y, speed, and direction, and 1 instance variable that's of type string, name. Then I have a test routine that makes an instance of a ship and assigns to the instance variables. Okay, so far so good, but then we'll see another example that's not so good. So I may be trying to do a ship simulation system where I am updating the x and y position of the various ships based on the speed and direction in which they're going. And we'll see that this slide is not so great, and we'll see, we'll talk a little bit about why when we come back to it. So, assuming that I'm running inside of Eclipse, I save both of the classes, and then inside the one that has the main, not inside the ship test, I right-click Run as Java Application, and I see some output. Now, it's very rare that you'd want to compile and run a class from the command line, but if you really need to, you can do so. When you do Java C, you would give the package name and then a slash. When you do Java, you would give the package name and then a dot. And in both cases, you'd be sitting in a folder that's the top level folder of your project, not in the package-specific subfolder. But that's exceedingly rare. Most of the time, you run it right inside Eclipse. And the point is that you only run the test routine, the one that has the main. You can't run a ship. Okay, that's the kind of high-level idea. Now let's go back and look at some details. First of all, the kind of format and structure of classes. You define the instance variables inside the class between curly braces. That's the only place you can define variables of this sort. There's no such thing as global variables in Java. You can have local variables inside methods, as we saw in the last section, and you can have instance variables, data members, fields, inside classes, and that's it. You can't have global variables. I also want to talk about the naming convention. Note in particular that the class ship starts with an uppercase S. That's a very strong convention in Java, and you should always follow it. Now, the compiler doesn't force you into this, but it's such a strong convention that most Java programmers would consider it wrong if you defined a class and you made the class name start with a lowercase letter. So class names start with uppercase letters, but basically everything else starts with a lowercase letter. So in the previous lecture, we saw the method called main. It started with a lowercase m, so methods start with a lowercase letter. In the previous lecture, we also saw that the argument to main was called args, lowercase a, so parameters to methods start with a lowercase letter. And then here we can see that packages start with lowercase letters, and instance variables start with lowercase letters. So classes start with uppercase letters, and virtually everything else, methods, parameters, local variables, and instance variables start with lowercase letters. All right, and then let's revisit this test routine, and we see a new piece of syntax, new. So the way to make an instance of a class, an object that belongs to the class, is to say new, then provide the class name and parentheses. Now later on, once we learn how to define constructors, we'll see that sometimes there are some arguments inside of those parentheses. But until we know how to define our own constructors, we say new, we say name of the class, we give parentheses, and have nothing inside the parentheses. Then the way to assign to an instance variable is to give the main variable name, S1, a dot, and then the instance variable name. There's no such thing as a variable name and an arrow. In C++, you could have either a dot or an arrow between the variable name and the instance variable. There's no such thing in Java. It's always a dot. All right, so far so good. But in the next example, we see that we have a problem. So suppose we want to update the x and y positions based on the speed and direction that the ship is going, some sort of primitive ship simulation system. Well, we can read the instance variables on the right-hand side of the assignment, and we can update them by assigning on the left-hand side of the equal sign. This is all well and good. But the problem is that I'm repeating myself. The way that I update the x and y position for the first ship is the same way I update the x and y position for the second ship, and I've just repeated all of the code. And the number one main goal of object-oriented programming is avoid needing to repeat identical or nearly identical code. Don't repeat yourself. That's the number one main goal of object-oriented programming, and I've just violated this tremendously. Although instance variables are very useful, this shows that we need something more. We need methods as well, and we'll introduce that in the next section.